So it's a very typical velocity time graph that I will give you. Okay, there's one on your test coming up, maybe a little bit more involved. You'll see when you do your practice questions on your problem set. So velocity time, velocity starts at 0. You don't know anything about position, but you don't really need to. We'll just assume it starts at position 0. We're gonna do this question twice. We're gonna start by doing what's called, or what I call, a qualitative analysis. So you're going to infer some information from the graph without doing any calculations. You might have to read some values, but there's no calculations to do. On the back part, we'll do the quantitative analysis. So there we'll be actually doing slope calculations, distance calculations, average speed and velocity calculations. Okay, so we might not get to that until Monday. We'll start with the qualitative one. All right, so here we go. In what direction was the initial acceleration? So initial meaning starting or first. So the slope of that first line is an indication. Is that east or west? East. Okay, so you can just write east. Keeping track of this stuff. It's east. Right, slope's positive. Slope is positive, it's east, based on the directions for this graph. Number 2, a little trickier. Describe the direction of the velocity and acceleration between 8 and 11 seconds. So just to reference it, there's 8, and there's 11. Now the acceleration is easy. That one's a little bit easier. We'll start with that one. The direction of the acceleration never changes. The acceleration is the slope of that line. It's negative. So the acceleration is westward or negative. Velocity, it's a little bit different. The direction of the velocity is the direction of the object. You have to break it up into parts. Between 8 and 10 seconds, this object was traveling east. At the 10-second mark, it's changing its direction. It's turning around. That's not really part of the question, but just for reference. So between 8 and 10 seconds, it's traveling east. Then between 10 and 11 seconds, it is traveling west because the velocity is negative. So between here and here, it's traveling east. And then there and there, 10 and 11 seconds, it's traveling west. Okay, so it has changed direction. So this question is just to look at that and look closely at the directions of what's happening. The acceleration is always in the negative direction, but the velocity started east, changed to west. Question 3, for how many seconds was the object not accelerating? So not accelerating means constant velocity. Just count the squares, count the seconds for your horizontal lines on your graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 seconds. So no acceleration for 14 total seconds. It doesn't have to be all in a row, just in total. At what times did the object change direction? So what time or times did the object change direction? Direction always happens when velocity goes from positive to negative or negative to positive. Even if it's a position time graph, it's the same thing. So it doesn't matter what graph you're looking at. So that only happens at one point, and that's at 10 seconds. So at the 10-second mark, the object has changed direction at that point. Did the object spend more time traveling east or west? So I'll leave that with you for a second. Looking at your graph, did the object spend more time traveling east or west? Yeah, kind of a trick question. Sorry for the tricky wording, but I wanted to try and make you think a little bit. They traveled the same length of time east and the same length of time west. When we're looking at the time, you're just looking at how much of the graph is in the top part for traveling east and how much of the graph is in the bottom part for traveling west, right? So anything up here was traveling east. Anything down below, that's traveling west. Well, only 20 seconds of travel, and they changed direction at the 10-second mark. So it's half and half. So this object traveled the same length of time east and west. Okay? Just because you've got more squares enclosed in your graph on the east part doesn't mean it spent more time there because it was moving faster. Number 6, in which direction did the object cover the most distance? So for distance, look at the areas. Look at the area contained between the graph and your time axis. So there's our graph and time axis for the west direction. And here's the between the graph and time axis for the east direction. Which area is bigger? We don't have to do the math for this. We can look at it. So did it travel farther, cover the more distance east or west? East, that's right. Okay. So for question was that? 6. Direction the object traveled the most was east. And 7, the final displacement of the object east or west of the starting point. So where did this object end up from the starting point? Did it end up east or west? If you did the math, would you get a positive result or would you get a negative result? Any guesses? Which area is bigger? Top or bottom? East or west area is bigger? East area is bigger. Right. So if the east area is larger, if there's more area contained in the top part, it went more east than west. So the resulting displacement or the final position will be east of the starting point. And so the last question, right down there, east again. Where you can make a little mistake is if you are looking at the graph and that final point right there is negative, but that's the velocity, that's the direction, that's not where it is. Okay, so yeah, the direction of the object was west, but from its starting point, it is eastward, but traveling west. So just pay careful attention to what the graph is communicating and where the values are.